So now we're going to look at an example from which we can see how we can use successive differentiation to find the higher derivatives of functions. So let's start with this question here. So the question says, find the fourth derivative of the function h of t equals to 3t to the power of 7 minus 6t to the power of 4 plus 8t cubed minus 12t plus 18. So we're asked to find the fourth derivative of this function here. So what we're going to do is simply use successive differentiation repeatedly until we get to the fourth derivative. So calculating the first derivative is rather simple and straightforward. So first of all, for the first derivative, we can just simply use the rule of differentiating powers for this problem here. So what we get is 21t to the power of 6 minus 24t cubed plus 24t squared minus 12 plus 0. Since differentiating this here is really equal to 0 here. So what we get is, if I write it properly, we get 21t to the power of 6 minus 24t cubed plus 24t squared minus 12. So this is our first derivative here. So now we're going to find the second derivative, which we denote as h double prime of t, which is simply the derivative of h prime of t. So to find the second derivative, we just have to differentiate this function here. So what we get is 126t to the power of 5 minus 72t to the power of 2 plus 48t. So now we're going to find the third derivative, which is again just the derivative of the second derivative. So using the rule of differentiating powers, again, what we get is 630 t to the power of 4 minus 144 t plus 48. So one more step left. Now we have to find the fourth derivative, which is again just the derivative of the third derivative. So finally what we get is 2520 t to the power of 3 minus 144. So this is the fourth derivative of the function h of t here, which the question has asked us to find. So let's look at another example where we will use successive differentiation to find higher derivatives. So let's look at this question here. It says, determine the third derivative of the function f of x equals to 4 fifth root of x cubed minus 1 by 8x squared minus root of x. So this function looks a little absurd because of all the roots, the fifth roots and whatnot. So we can assemble this in a much simpler way. So we can substitute this to look like 5 by 3 minus, we can just bring the x upwards and we will have 1 by 8 x to the power of minus 2 minus this is simply x to the power of half. So now we can work with the rule of how we can differentiate powers to solve this problem here. So for the first derivative, we just simply again use the rule of differentiating powers, and what we get is 12 by 5 x to the power of minus 2 by 5 minus, so this minus comes to the front, so we get plus 1 by 4 x to the power of minus 3 minus half x to the power of minus half. So this is our first derivative, and we're going to find the second derivative, which is again simply the derivative of the first derivative. So what we get is minus 24 by 25 x to the power of minus 7 by 5 minus 3 by 4 x to the power of minus 4 plus 1 by 4 x to the power of minus 3 by 2. So we're going to go ahead and find the third derivative now. So what we get, so again, this is just the derivative of second derivative. So we're going to differentiate this. So what we get is 168 divided by 125x power of minus 12 by 5 plus 3x to the power of minus 5 minus 3 by 8 x to the power of minus 5. So this is our third derivative as asked from the question. So now we can just assemble this to look something like this for the final answer. So what we can do is we can write it like this. So 168 divided by 125. So this, since it has a minus, it goes down. So this will be the fifth root of x to the power of 12 plus this we can write it as 3 divided by x to the power of 5 minus, again, negative, so this goes down. So we get 3 by 8 square root of x to the power of 5. So this is our final answer here, which is the third derivative of the function f of x.